Spheres have no net. You know all the other formulas we had? We could build them from two-dimensional figures, and we could build the shape. Spheres, you can't do that, right? Because all a sphere is a circle that has been spun infinite times around a central point in an infinity of directions, right? You spun it this way, and then you spun it this way, and then and you were all over the place, you made a sphere. That's what you have. It is an infinite number of circles, right? So as soon as you know there's a circle involved, pi's got to be involved. Now, what they did to figure out these formulas was experimentation. Okay, and what do I mean by that? You guys all know the story of Archimedes jumping in the bathtub, yes? Eureka? You know that story, right? The king of Greece got a crown, and he said, I don't think this... Well, he said it in Greek, because he was the king of Greece. I don't think this crown is pure gold. I want to know if it's pure gold. And he gave it to Archimedes, and he said, Archimedes, again in Greek, find out if this is pure gold. And Archimedes was like, I got you, your majesty. But he didn't know what to do. Yeah? And then what he did was he weighed the crown, and he found the weight of the crown, and then he got a piece of gold that was the same weight as the crown, that was pure gold, that he knew was pure gold, and then he dropped them both in a bathtub because the density's changed when it's not pure gold. Density, mass divided by volume, science, 8, nothing. Okay. You know when you get in the tub, the water goes up. Okay. Archimedes jumped in the tub, the water went up. He said, of course, density. And then he did the thing with the crowns. And then he found out the crown was pure gold and everyone was happy. That's what they did to find out spheres. Okay? They took a bin of water, dropped a sphere in it, and used subtraction to find out how much volume the sphere had, and then worked backwards from there. Cool? All right. That's really all that matters. That's how they got the formula. How do we use the formula? We use the formula the same way we use every other formula. All right? Except there's some weird stuff when we get to spheres. Okay? These two are pretty self-explanatory, right? 4 pi r squared, pi d squared. That's surface area, easy peasy. Remember, because it's pi, you're going to leave your answers as pi, right? This one is a little more troublesome. I don't like writing this equation this way. I don't like writing this equation this way because it messes people up. I like to write this equation as 4 pi r cubed, then I divide by 3. That's how I like to do this, okay? Now, before I go any further, we need to spend a moment with these two because these two are weird because weird stuff happens to them, okay? So spheres are cool, right? Everyone's all right with that. If I gave you some numbers, you could plug them into the formula, you could make the surface area, yes? All right. Where we get into trouble, and please draw a line there, is hemispheres. Forgot the P. Hemispheres. Okay. What's a hemisphere? It's...
Like, okay, that picture right there, it's with this circle.
Yeah. A hemisphere is half a sphere. Okay? Half a sphere. Now, Tavleen, little dizzy there, has brought up that in her mistake, because she's very embarrassed right now, she shouldn't be, she talked about this circle here, yes? That circle is very important to the hemisphere because everyone forgets about it, right? If I tell you a hemisphere is half a sphere, then what would you do to this formula if the surface area of a sphere is 4 pi r squared? What's the surface area of a hemisphere? You would divide by 2, would you not? And what would you get? you would get 2 pi r squared, yes? Right? Makes perfect sense, yeah? Except, Havleen, why is that wrong? You have to add that circle, don't you? Because when you cut a sphere in half, you make a new surface. Understand? And that surface is a circle. So I have to add, what's the area of a circle? Pi r squared. So what do I have there? I got 2 pi r squareds and 1 pi r squared. So how many pi r squareds do I have? 3 pi r squareds. That is the SA of a solid hemisphere. Right? What if it's a hollow hemisphere? Then what is it?
Would you just take away the surface area of the circle?
Possibly. What would happen then? It would be 2 pi r squared, right?
Yeah.
Okay.
Okay, and just follow well, and you just keep that as a whole sphere, so you got the inside of the circle and the outside.
Understand?
Yeah.
Right? Surface area is everywhere that's visible, yeah? If there's no top on this cup and I dip this cup into paint, this is all going to be covered, isn't it? So the surface area is inside as well. Everybody with me? Thinking, right? Okay, so that's good. Now, oops, damn. That covers surface area. Volume is a little trickier. 4 pi r cubed over 3. Volume of a hemisphere. If I cut it in half, is anything added? No. I'm just losing half the volume, yes? So I must just divide this by 2, correct? Now dividing by 2 means I would put that whole fraction and divide by 2, yes? Barf. That's ugly, isn't it? So what I like to do is this. It's times 1/2. Now, does 1 multiplying by the numerator change it? No, so it's still 4 pi r cubed, but it's over what? 6. That's the volume of a hemisphere. Everybody cool? You won't find those on your formula sheet, will you? No. That's the type of thing that you learn in the class to do. Everybody with me? Picking up what I put down, read my mail, mow my lawn? All right. Let us move on, cabbages. This is my favorite example of an idiotic math class question. Because, of course, were you to wrap a basketball for your brother, you would not wrap it as a ball, because that would be idiotic. What did she get me? I don't know. You would put it in a box. Or you would take the air out of it and roll it up and give it to him as a tube. You would not give him your prize. But I like to take questions from textbooks that are old, like when I was in school, and show you guys, this is what it used to be like. Questions like this. So, do I care about, in this question, the surface area or the volume of the ball? Surface area. Why? Because I'm not wrapping the inside. That would be even stupider. Okay? So, again, we got to use our surface area formula. We know that the surface area is 4 pi r squared, don't we? Now, in reality, the only thing we care about when wrapping a present is getting enough paper around it, right? When you wrap a present at Christmas or birthdays or whatever holiday or occasion you have to give a present, do you measure the present? Of course not. Do you find the exact surface area and then cut that out perfectly from the wrapping paper so it wraps? No! You do one of two things. You do the smart thing, which is take a look at it, put it on the wrapping paper, roll it over twice, add a little bit for mistakes, and then wrap it up. And you always have a little left over, but that's okay because you fold it under and you tape it and it looks beautiful. Or you're stupid like me, and you're like, I can do this, and you put it down, you roll it around like, well, and you do a bunch of math in your head, then you wrap it up and you end up with about that much not covered. And then your wife goes ape poo because you've cut a strip off another piece of wrapping paper and laid it down there and said, it's on the bottom, they're going to tear it off anyway. And then she goes ape. Am I on the right track with any of you? Okay. Do any of you have a father who, when he wraps presents, it's a piece of crap, and when the wife wraps presents, it's gorgeous? Yes, okay.
My dad is.
Your dad is the nice present wrapper, and your wife is not your wife. What is this, 1400? Your mother is the bad present wrapper?
Dude, I don't know. I guess
That's very strange.
Maybe they're both good.
That's an interesting family. Because I am a poopy present wrapper, even though I'm the math teacher. Anyway, so for some strange reason, I am wrapping this basketball for my brother, and I really care about the radius of the basketball. It's making a significant difference in my life. I'm not entirely sure if I'm going to be able to go on to Christmas morning if I do not know the radius of the basketball. I'm sorry, that was very ethnocentric of me. I don't know if I'm going to be able to go on to the next morning of gift giving when because I do not know the radius of the basketball. But I do know that the surface area happens to be 2,500 centimeters squared because, of course, I measured my wrapping before I wrapped it up. That is the type of question that makes the people who decide how to teach you guys math angry. Because they're like, that's not a real life question. Shut up. They shouldn't have to do that. And I, of course, argue, no, you shut up. Because this actually makes them think about the numbers. And what is math if not thinking about numbers? And then they have no argument to that, so they take their basketball and go home. Actually, what they say is, sorry, we're the ones that are in charge, and you have to do what we say, even though we don't teach kids. That's really what they say to us. Notice I did that as a gesture, so it will not be recorded. All right. So what do we know here? I know the surface area is 2,500. And again, I cannot get ahead in my day until I know the radius. So what do I have to do here? Algebra, right? If I gave you this, 3x equaled 9, what would you do? You would divide by 3, right? Because you got to get the x by itself, yeah? So I need r by itself now. So what do I have to do? Divide by 4 pi. So they're going to cancel, yes? Right? Okay. So now we've got this yucky situation. Equals r squared. What do I do to get rid of a squared? What do I do at the end of Pythagoras? Square root. So what do I do here? Square root. Because even though it doesn't look like Pythagoras, it's the same thing, isn't it? And math, if you learn one thing in a math class with me, learn this. Looks don't matter. If there is something you do to solve a math problem, then no matter what the math problem looks like, you do that same thing. Right? So I'm going to square root both sides, and the answer is the square root of 2,500 divided by 4 pi. Barf! Now, let's think for a second. Is Mr. Myers going to be happy with that answer? You got a 50-50 shot. Yes or no? No. I meant where we are right now is barf. Like, what do you do here? Am I happy with that? Do you think? Does that show me you understand the formula and algebra?
Yeah.
Is this math class? Do I like it if my students understand the formula and algebra? Yes. I am perfectly pleased with that. You guys won't be. You guys will be like, I gotta know, man. And you won't be able to punch it into your calculator properly. You'll screw it up. Okay? And some of you will punch it into your calculator, and I'll punch into my calculator, and I'll be finished, and you'll still be on like the second zero of 2,500. You'll be like, I don't know how to punch it in. which again is fine. As you practice more and more with calculators, you're going to learn how to punch this in all in one step. Okay? But it does take practice. All right? Now, I would like for everybody now who has their calculator handy, try to get me a number to 2 decimals for this value. Okay? Try to punch it into your calculator and let us see if we are comfortable with it. Now, some of you have already done it, I know that, but as you can hear, your peers are getting their calculators out now. So give them a chance. That's all I ask. My nose is running. I need to go catch it. Now, guys, I guarantee you I am going to get a whack of different answers here. And some of them are going to be correct, and some of them are going to be wrong, and some of them you are going to think they are right, but you're not actually very good with radicals yet. So even though you think you may have done the right thing, you might have screwed it up too. Don't worry. That's the whole point of this. If you understand this, you are where I want you to be. Because this is not calculator 10, is it? Right? This is not calculator 10. All right, who has some radii for me? You won? What'd you win? A which?
A coffee.
A coffee, nice. Now, if you'd just done that beforehand, you could have enjoyed your whole coffee without the stress of wondering if you were going to win or not.
I got coffee.
Whatever. My wife threw one away, so of course that was the car.
No.
Like that teacher in Quebec. I would like to say, on behalf of teachers everywhere, if I threw away a cup and one of you found the cup and it was the car, I would let you keep it, because I'm a moron. If you want to dig through the garbage like a bum and find that there's a car in there, you're welcome to have it. I would not have been angry like that teacher in Quebec.
What happened?
Teacher in Quebec drank the coffee, threw the coffee out. Kid went to the coffee cup, dug in the garbage like a bum, pulled it out, unrolled it, won a car. No. Teacher said, "That's my car," and they went to court. Yes. I don't know who won. I don't know how it came out. But all right, who's got a radii for me? I have 14. Oh, my goodness gracious. I have 14.1. What else?
Do you want to know, like, honestly?
I want to know what you have.
44.3.
We have a 44.3. What do you got?
I got 25 pi.
We got a 25 pi, which is somewhere around 75. What else have we got? What else? That covers everybody's answers? That's frightening because none of them are right. So somebody give me another answer. 3.98. Your basketball is 3.98 centimeters. So that's the radius, so that's 4. So your basketball is this big. Duncan, what do you got? We got a 78 from Duncan. That's the 25 pi probably, is 78. So yeah, good. We got a 12.5. 12.5 pi. Okay. So you got 12.5 pi. Just 12.5. And you got 39.27. Yeah, I understand. That's the point, right? I'm trying to show you guys. Look how many different answers we got. Now, does every one of you in this room know how to multiply, divide, and find square roots with your calculator? Yes. So you all could do this, couldn't you? But we all have different answers. So somewhere there's a problem here, yes? Where is the problem? Is it your math, or is it your ability to manipulate your calculator? It's the ability to manipulate your calculator, okay? Because your calculator doesn't know a darn thing until when? Till you tell it what to do, right? So let's look at this question. Let's think about it. Somebody already mentioned the word bed mass. Let's think about this from a bed massy perspective. What does this question mean? If I ask for you to give me the square root of 4, do you know it? What is it? 2. Agreed? Okay. So what if I wanted the square root of 32 over 8? What would you do first? Because you can do that in your head. You would divide first. What's 32 divided by 8? 4. So isn't that the square root of 4? So isn't that still 2? Cool. So knowing what I just showed you, what should you do first here? If you were not able to do this in your calculator in one step, you should do the division, yes? So that's 2,500 divided by 4 pi. Now, some of you, I bet, went 2,500 divided by 4 and got 625 pi. Did any of you do that? Of course you did. Why is that not okay? Because this is really 2,500 over 4 times 2,500 over pi. Pi is dividing in both. Understand? So, you couldn't do that. Oops. But wait. Some of you will say, okay, you got to have brackets around the bottom. So to do this on your calculator, you would need to push 2,500 divided by bracket 4 times pi, close brackets, then equals. Everybody cool? Then what would you do with that answer? So you would do that on your calculator. 2,500 divided by bracket 4. Now on my calculator, I can just go 4 pi. I don't need to push times. Some of you can do that, some of you can't. Okay? Some of you need to push times pi there. But you all need the brackets. Because if you don't put the brackets, you're going to do 2,500 divided by 4, and then that times pi. Do you understand what I'm saying? And that will give me 198.94, yes? Everybody cool? So now I've got 198.94. Now that's sitting on my calculator, yes? That's not the final answer, is it? So I want to leave it on my calculator. What do I need to do to that? Square root it. So I go second square root. There's my square root button. I don't want to type all that in. I'm going to show you guys this particular key that will become your best friend as you proceed further and further in math class. Find on your calculator, it's hard to see, but ANS. I think I might have talked about it with you guys before. ANS is your calculator's working memory. It is the last thing you got when you hit equals. Okay? So the last thing I hit equals for got me 198.94, didn't it? So if I go square root, and for me, you can see it's a second function, right? So for me, I go second answer. Square root of my last answer equals 14.1. Somebody said 14.1. Yeah, somebody did get it. Good. I feel bad then. Sorry, somebody did get it. Everybody cool? Now, if you desire to get this all in one go, it is still possible. Square root, right? Bracket 2,500 divided by bracket 4 pi, close brackets, close brackets. Okay? Everybody understand? These outside brackets cover the whole thing, and these inside brackets keep 4 times pi together. Okay? 14.1. Everybody cool? Okay, now remember, I just spent a long time with your calculator, yes? Even though I've just spent a lot of time telling you, I care more that you understand what is going on than know how to work your calculator, right? While that is true, you do need to, eventually, you will be going into places where you will need to know how to use your calculator. Like it won't be an option. Do you understand what I'm saying? So being able to do stuff like this is going to become more and more important. All right? Which is why I can't stress enough. If you do not yet have a calculator that actually shows what you are punching in, like this, you want to go and purchase one. Okay? One that actually writes out the brackets and stuff. It has 2 lines of display. You understand what I'm saying? You know if you don't have it. You want to get one that does that. What you really want is to buy this one for next year because you all need it. No matter what course you take in grade 11 math, that whether it's IB, pre-calc, or foundations, you need this calculator. And it costs about $100. We'll lend them to you, but it's tough to do your work at home without it. Okay? I really recommend it. All right? Okay. So 14.1, good. Who got 14.1, by the way? Well done. Everybody else? What was it? It was calculator issue, not math issue, right? Now, some of you, one sec, put a pin in it. Some of you equate your ability to use your calculator with your mathematical ability. Please do not. That is why I ask you to show me work. Okay? Everybody with me? Now, what would I do if I gave this as a question and I told you I wanted an actual answer? And you went and had one of these wrong answers? If the question was out of 4, I would give you like 3.5. Do you understand? Okay, because this is what I care about right now. We're not putting a rocket onto Pluto. Okay, I don't necessarily need this yet. But you need to know how to work your machine. Cool? Because the next unit we do, you cannot do in your head. At all. The last step to do our next unit, you need your calculator. Everybody cool? Okay, go. Take the pin out. Go. Yes. I was hoping for more there. That's okay. Oh, my computer's not working anyway. Okay. Where did we get to? There we go, 14.1. Okay, so let's look at the next question. My man Jim. And this seems like a math class problem, doesn't it? But it's actually not. This is the type of thing, there are people that work in factories and for companies that have to package stuff. And you guys are aware, packaging costs money, right? If you're going to buy something that's in a box, you are paying not only for the thing you are buying, you are paying for that box. Because the people who made the thing that you were buying paid for that box. Do you understand what I'm saying? So companies do their best to try and minimize packaging. They tell us it's for an environmental standpoint. But that is, of course, a big lie. It is to save them money. Because if they don't have to package it, that's less that they have to spend money on. Right? So, here we have a question. He places 3 golf balls into this box. If the balls fit perfectly snugly against the sides of the box, find the volume of the box which remains as empty space. Now it's a math question. Because who cares, right? Who cares? So let's talk about this question. What do I have? What shapes do I have with which to work? I have how many spheres? 3, right? So I have one sphere is 4 pi r cubed divided by 3, yeah? But how many of them are there? 3. So what do I get to do with that? Multiply by 3. What happens to those 3's? They're gone. Before I've even done anything with the question, I've saved myself a ton of work, haven't I? So the golf balls, the volume of the golf balls is 4 pi r cubed, yes? Right? Okay. What's the volume of the box? 3 times 3 times 9. Length times width times height, right? Right? Now, what math will allow me to find the empty space? Subtraction, because it's the difference, isn't it? It's the volume of the box minus the volume of the golf balls. So 3 times 3 times 9 minus 4 pi. What's the radius? This is a trick. What's the radius of the sphere? $1.5. Right? Now listen to me. If you go to here, if you go to this entire line with your calculator, there's a chance for screw up, isn't there? Why? What about that line leaves you open to a mistake on your calculator? Brackets, exponent, and just the sheer amount of buttons you got to push, right? So simplify first. What's 3 times 3? What's
9.
What's 9 times 9? So we can get rid of that right away, can't we? Before we even go to our calculator. 81 minus. Now this, again, most of you could probably punch that into your calculator, but some of you will have trouble with that, right? If you're going to punch that in one go, what do you think you have to hit? What math is right there? Multiplication. Some of you won't have to hit that one, will you? What math is right there? Multiplication again. And what is that? It's another multiplication, but it's an exponent. All of you have an exponent button. You used it last year. Here's the problem. Everybody's button on their calculator looks different. Some of you have this, X with a little y. Some of you have Y with a little X. Some of you have what's called a caret, looks like a mountain. Some of you have X to a little blank. Some of you have Y to a little blank. You got to know what your machine does. So if you were going to punch that onto your calculator in one shot, 4 times pi button times 1.5 exponent button 3 equals. Right? Now, that's going to give you an answer that you could write right there. If you were going to punch this all into your calculator in one go, it would be 3 times 3 times 9 minus bracket 4 times pi times 1.5 exponent 3 close bracket equals. Do you need to do that to get this answer? Or can you do it in stages? You can do it in stages. It's fine. Everybody cool? So, what did you get when you punched that in? $42.41. So you should get something around the neighborhood of 38.588. Yes? Okay. Again, I remind you, this is not calculator 10. Never will I give you extra points for being able to do this in one shot. Okay? Ever. All right, and that's it. So you guys have page, it should be 35, 36, 37, and 38. And that's it. 37, 35 to 38. You guys have...
We have 30, 31.
Oh, sorry, my numbers, just because my numbers are different. 1, 6. You're doing 1-6, which on my book starts on 35. Sorry, thank you, Stanley. I keep forgetting that my page numbers aren't the same as yours. I don't even know why. It's the exact same file.
Then how? Oh, because maybe your pages are longer.
I think what happened is mine counts the outline pages at the beginning, and I don't think yours does.
Yeah, our outline pages start on like the blue page.
Yes, I'm aware of that. I'm a little frustrated by the people that printed this for me. So is everybody Gouda? Great. Carry on. My wayward sons. Yes.
What number is it? 30 to 31.
So what is the pages in your book, guys? 30 to 35? Or 34?
30, 34. No, yeah.
30 to 34? Worksheet 1-6. Please notice, sometimes I ask for surface area, sometimes I ask for volume, sometimes I ask for both. Pardon me? Is 34 problems and applications? Then that's where you stop.